Hi there, this is session 28B of programming from the very basics using Python. This is a continuation of the last session where I couldn't complete it, though it spilled over almost like 1.5 hours. So I had to continue in another session. So I hope you would still find this useful. So let's continue with where I left off. In the previous session, I think I talked about scope of a variable. I told you that variables which are defined inside a function are scoped locally. So if you define anything inside a function, they create a local scope and they are resolved first within that function. And if at all you don't have a definition locally, like you have a variable that you're trying to access in a function but it's not defined inside the function, it tries to resolve in the global scope. That is assuming it's a simple function. But if this function happens to be an inner function in an enclosure or enclosed function, then it's very likely that it's going to access the enclosed scope before resolving to the global variable. So we saw this example where I sort of explained with this enclosed scope. I think, yeah, this one. I just left here in the last part of the session. So I'm just going to continue with this code. So you remember in this case, I defined a variable which is a global variable. I define a function called testfn. And here I just commented it out. So to say that when I try to run this code right now, it's going to resolve the global variable here, right? It's going to resolve to 100. So you can just see that in this place. Python, I just called this as local enclosed global scope this time. So now you can see that A is not defined locally. It's not defined in the enclosed function. So it's going to access the global variable. But suppose I uncomment this line, and now when I try running it, you can see it accesses a variable that's not defined inside foo, but is defined in the outer function or the enclosed function. This is another level of scope resolution. Ultimately, if you have a local variable defined, that will take the precedence over the enclosed scope and also the global variable. So if you just try running it now, I think I didn't save this file, sorry. Let me save it and run it. Yes, now we can see that A is equal to 300, which is now the locally scoped variable. That is what is being resolved. So you can see there are 3 levels. The 4th level I didn't really discuss because I used a variable called A, but if it was a variable like, say, which matches some built-ins, maybe if I use something like len, maybe it would have made sense, right? So len is a built-in function, but if I create len is equal to 300 as a local variable, I cannot use the len function anymore. I can access len as a variable locally, but if at all I don't have len defined as a local variable, but if it's defined in the outer function or the enclosed function, if you might call that, you can see that it'll access the len function in there or len variable there. Otherwise, it's going to access the global definition if it exists. If it's none of these exist, len would be a built-in. So you can see print, len, all of these functions are resolved through built-in scope, right? Because we don't have those definitions anywhere in here. So obviously it's going to resolve to built-in. I've seen this as an acronym called Legbe rule. I don't know who coined it. I thought it's David Beasley. Let me know in the comments if you have read his book. I'm not. So it's a thick book and I couldn't get it in India. So, and then those days, but this book is very popular, I guess, on Python. So I don't know. Maybe it was defined by him, or is it just a jargon that sort of made its way into the internet. This is called as LEGB, which stands for Local Enclosed Global followed by Built-in. That is a rule for name resolution. Now, having said this, now it will be very clear to you what this non-local does. I'm going to explain that. Now it will be very clear. I think I created a file called non-local. I'm going to overwrite that file with this version. So it's more, it will be more clear. Yeah, this is the file. Overwrite it. Now, in here I said A is equal to 300. So obviously it modified the local variable. It created a local variable. It's not modified. Just created a local variable, and that's what I printed in this function. I'm calling foo inside testfn. And after calling foo, I'm just going to print in testfn A is equal to, right? And then here in main, I'm just going to call in main A is equal to. just trying to print the value of A in all three levels. I'm setting a value here inside foo, and I'm printing it. Foo is called inside testfn itself. After foo is being invoked, in testfn, I'm trying to access the value of A. I'm calling testfn, after which in main, I'm trying to access A. Now let's look at the output here. In main, you get access to the global variable. In testfn, its own local variable, which is technically an enclosed variable inside foo, but there's a local variable in foo that takes precedence over it. So in testfn, you get 200. That variable is not changed, right? Whatever value I set, that's what is printed. And you can see that in, I should call this not testfn, it's called foo, right? I made a mistake here. Silly. Sorry. Let me just change this and run this one more time. In foo, it is 300, which is a local variable. In testfn, 200, which is a local variable of testfn, which is also an enclosed variable from the perspective of foo. And in main, you can see the global variable, that's 100. I mean, the value is 100. Now, inside foo, if at all I try this, if I just type non-local A, I just use a non-local directive at this moment and try running it now, you can see what happened. In testfn, I defined A to be 200. But after calling foo, when I try to print in testfn the value of A, you can see it shows up 300. What really happened? Because I use a non-local directive or declarative, you can call it, for A, it's a kind of hint to the compile time to say that bind A to the enclosing scope, not to the local scope. Bind A to this outer scope, not this local scope. So when you try to reassign A to 300, it's going to reassign this variable to 300. And that's what happens when you try to print A after that in testfn. But instead of non-local, I'll just comment this out, okay? And just try globally instead. You can see that it did not modify the variable in testfn, but it went ahead and modified the global variable. So this is what non-local does. To be honest, I have not seen any code that uses it. That's why I sort of forgotten how it worked. So last session, I sort of stumbled on it and wondered what it does and tried to experiment. And again, this is what I can see. But you know what it does, right? It's similar to global, but to the enclosing scope, right? So I'm going to leave this here. I'm going to uncomment this. I'm going to leave this commented so you can experiment and try this out. Now, having told you about these scopes and how they work, so without the global directive or non-local directive, you cannot modify any variable outside the function scope. That much is very clear. So every variable you define would be locally bound to that function scope as such. You should also note at this moment that only functions create a scope. None of the other compound statements do. Okay, let me just exclude classes from this perspective. Classes do something else. Let's not worry about that now. I'm going to leave the classes off. But the flow control constructs, I'm talking about the if condition, the while loop, the for loop, and what else? The match case construct. And maybe I didn't cover try except blocks. Even that is included in this. And also with clause. If you define any variable inside those blocks, the variables are visible outside them. If you define a variable inside an if condition, and the condition is true, the variable gets defined. Now it's visible outside that scope, outside that block, I would say. So there is no block scoping in Python, which is quite prevalent with declarative languages like C++, C, and even Java. Because there you declare variables, right? You declare a variable inside a block and that variable is scoped inside a block. For example, you declare a variable inside a block that belongs to a for loop. The variable is only part of the for loop. Privatized to the for loop, it's not accessible outside it. There's a compile time check to manage that. So every block can end up creating its own scope for all the declarations that happen inside them in these languages. But in Python, that does not happen. If you define a variable inside a for loop, or inside a while loop, or inside if condition, those variables are accessible even outside them. Just as a simple example, I'll just show you maybe I'll show it in a notebook here. Maybe here I'll just type flow control blocks do not create their own scope. So let's try a very simple for loop. I'll say for I in range of 10, and here I'm just going to type j is equal to I into I or something. It doesn't matter. Okay, the logic is nothing great here. What I'm trying to do here is that I'm just trying to create a variable called j, and this variable will represent the result of I into I. It's not going to be accumulative at all. Don't worry about this. The logic is not something that's useful. Okay, but I'm just trying to show you that I've created a variable inside the for loop. Now, after this for loop completes, I can access outside the for loop the value of I and j. So these two variables are actually global variables because they are not inside a function, by the way. If they were inside a function, they will end up creating local variables accordingly. So this is something that you should keep in mind when you are defining variables. So you should note that variables that you define inside any block that is that conforms to flow control, if condition, while loop, for loop, try except block, with block, these 5 flow control constructs, they do not create their own block scope. Any definitions inside them would either be local variables or global variables depending on where those blocks exist, whether they're inside a function or outside a function. That's it. That's something we should know. And the confusing part, another part you can see is that what is this variable? Some people might ask, oh, what scope is this? From the perspective of testfn, it's a local variable. But for its inner functions, functions which are within this testfn, this variable is an enclosed variable. I always tell you that. This variable is an enclosed variable from the perspective of foo. But in testfn, it is a local variable. Okay, so something that you should be clear about. Now I should tell you about some interesting things that you should know when you relate it to scope again. This is an important one. I'll just create a new file. But before I create a new file, I'll do one thing. I'll open a file here. And I was trying to create global var modify. Yeah, this one. This is what I want to show you. You know what happens when you run this program? I think I talked about it. You have a global variable here. I have a function that's defined called testfn. And inside this function, I'm trying to access this variable, after which I'm trying to set it to 200. So when you run this, what do you think will happen? This was in fact almost the first program I showed you. I think it's the second program. We saw there was an error, right? Where was the error? In the print statement. We saw an error in the print statement. And what was the error? The unbound local error. If you try running this again, just to remind you of what happens. You can see it shows this error, unbound local error, local variable A, cannot access local variable A without where there's no value defined or whatever. It just prints that message, right? You can see that message in here, but you can see the error has got to do with the print. If you swap the print and put below this, it's going to work because you're trying to access a variable after it's being defined. Because really all definitions create a local scope, right? That's very clear. Now I'm going to change this. I'm going to make a small change here. I'm going to save this file as, maybe I'll call it as global var modify mutable. An interesting one. This time I'm going to type a is equal to, instead of 100, let's make it a list of 100, 200, and 300. Right? Now I'm going to just make the change here where I'm going to say a of 0 equals, let's make it a number like say 111. So I guess you know what I'm trying to do here. I'm trying to modify a from inside a function. What do you think should happen? Just think. Maybe you can pause the video and try this out if you want to. Well, if you try this, you'll be in for a surprise because all I did was I changed the variable to represent a list rather than a number, right? When I try running this now, there was no error. There was no error. I did not use any global qualifier there. I did not define anything. I did not declare as global inside TestFN. But I was able to modify an object represented as A globally from inside a function without any problem. Now, I mean, you might wonder, how is this possible? Let me tell you. Variables have a scope for name resolution. Objects do not. That list is an object. And this list object, I use a list here. Why? Lists are mutable objects. And what you did here is you did not reassign A to another object. If I did this, for example, if I start typing A is equal to A of 0 is equal to 111, if I tried out this, if I said A is equal to, create a new list which has got 111, 200, 300, changing it to another list altogether, this will raise the error. You can see that right here. The same error, the unbound local error. Let me just clear the screen and show you. So when I run it this time, it raises the error, which says unbound local error. Let me just try to maybe reduce the screen font size if I can, so I can see the messages better. Yeah, okay. Sort of. Yep, you can see that. It shows unbound local error, cannot access local variable A where it is not associated with the value. It's the same message that you got last time when I tried with a simple variable, because this is variable assignment. You're trying to make a label that's a variable point to another object. That's what you're trying to attempt. But when you try this, you're not reassigning the variable. You're not making A point to something else. A is still referring to the list. But the list being mutable, I can access the list item and change it. There's a set item operation. Do you see where I'm going here? Here's what you should know from this. A takeaway from this. If you have a global variable that refers to a list, a dictionary, a set, or any other mutable object, you can mutate it from anywhere in your code. Scary thought. This has been a problem in production. So I've seen some code base which is like quite long, 1,000+ lines of code in a single file. Yeah, you should modularize it, but sometimes, people just add code and the code just gets slowly big. And there are a lot of global variables which are defined, which represent dictionaries and lists, perhaps. Mostly dictionaries where what I see there, config dictionary and so on. All these kind of dictionaries exist. They're all defined globally. The problem is that when you have a dictionary that's defined through a global variable, that's totally unsafe in that code. Because any part of the code can go mutate a dictionary and it becomes really worrisome. It's very difficult to find out which code did it. So there's something that you should keep in mind when you're trying to define any variables which represent mutable objects. How do you solve it? It's a question. Avoid it. No, I need a dictionary. I need that dictionary because I want to use this in all other code bases. Scaffold it. Enclose it. To use some kind of enclosing mechanism. And that's what classes are really meant for. You define it in a class. You make that an instance attribute. And you provide some kind of methods to safely handle it. When you believe that multiple components are going to use them. And this way you can track who's using them and you have better control. So you don't want some dictionary to be cleared or corrupted in the wrong way. So you can do some validation there. And that's exactly where classes and objects come to play. Right? Some of you might argue that, oh, I can't really do encapsulation in an object. No, it's not about that. If a programmer who's using your code is going to deliberately go and access the attribute and mess around with it, you can identify that by looking at the code. You can look at that code, which is going to access that attribute. If your dictionary was an object's attribute, and you want to tell a rule that nobody is supposed to access this attribute directly, use these functions as a safety function. But if somebody in your team try to go and access this attribute, you can figure it out. Unlike when you have a code, when there's no scaffolding, it's all left in the open. It's like a Couple of dollar bills thrown on the streets. That's what this is. Anybody can steal them. Anybody can use them. So that's what it is. So you need to scaffold it and have some kind of safety net to make sure that everything goes through this path and you can track it. And if they violate the safety net, your code will show that, will reveal that, and you can figure it out. That's the mindset you have. There are other languages which have strict encapsulation principles like C++ and Java. You can do something like that in Python, but I would not recommend it because it hurts maintainability in the long run. I will show you how it is done, but I'm going to tell you to avoid it generally, right? So if there's a C++ developer or Java developer says, sometimes we have these people fighting over languages, right? So they say, oh, in Python, you can't have private members. You can tell how to do private in Python, truly private members, and you can do it. You can perfectly do it without the private keyword. That is, requires a little bit of code. So you can have a very restrictive encapsulation implementation in Python, but it's generally not recommended to use because your code becomes too rigid when you do that, right? But it's better that you leave it open and track them and look at the code when something is going to modify that, when it's not supposed to modify, and that should be easy to track. And that's how you build your code base, right? That's how you see your Python code being built. All these falls into the territory of object-oriented programming and design of object-oriented programming design. But let's focus that a little later. But for now, scopes, you should know what it does. At this moment, though I didn't cover about classes and objects as yet, one thing I should tell you, what this is for programmers who come from other language backgrounds who did object orientation in Java or C++ mainly. Classes do not create a scope. They don't, right? They don't create a scope. They don't participate in the scope resolution. So all definitions inside a class become attributes, and attributes can always be accessed using the dot operator. That much I should tell you. So they don't have a concept called name resolution via scope. Here I'm using print. I don't have to say something.print, isn't it? How is Python able to figure out where is print coming from? It resolves it to built-in module because there's no other definition here in this entire path. There's no global definition, no local definition, nothing. So print is built in. If I try to access A, it figures out where A is defined locally in a function, in an enclosed function, or in the outer function, and resolves it there. So name resolution is got to do with just names without the prefix dot qualifier. So when I say time.ctime, remember time.ctime. Time is a module. Time is an identifier that represents a module object. That module object has a definition of time, right? ctime, let's say ctime. You're accessing that. That's an attribute access. You're accessing an attribute. In fact, you should note, if I try to access a variable that's not found in Python, let's say I'll do it like this. I'll just type some variable, ABC. What do you get? Name error. You get name error. Let's try something like import time. Time.now, for example. This kind of functions exist in many other languages. I know in Ruby it's there. It's found in many languages. Let's try in Python. You don't get name error, you get attribute error. It says module time has no attribute now. That happens because you didn't type now like this. That is name error. It's not able to resolve locally, enclosed, globally, or built in. That's the ultimate resolution. But in this case, it doesn't have to worry about that. It checks whether it's defined as a global variable or a function here. In this scope, it's not. It checks built-in. It's not resolved in both places, so it raises name error. But when you try something like time.now, time is defined in my current scope because I imported the module. But in time module, is there an attribute called now? That's what I'm checking for. The now is actually a definition inside that module. All definition in the module becomes module's attributes. So you're living in the main module. Time is another module. It's like a neighbor's home. You're trying to access from your neighbor's home. That's how you're doing. And when you try doing that, you get an attribute error if it's not found, right? Something that is no. Anyways, so in summary, I should say that attributes and names are treated separately when it comes to how they are resolved in Python. Attribute resolution has a really sophisticated, complex rules, I would say, especially when you start talking about multiple inheritance, which Python supports. It's quite complicated. Though we don't do multiple inheritance as much these days to avoid complexity. So the rules are more complex there. Let's not worry about that for now. I'll talk about that when I talk about object-oriented Python features. All right, so I talked about this scope. I told you what happened when I tried to mutate an object using this statement. Remember, this is not variable reassignment, but a form of object mutation. I'm just putting it in a comments in here for your reference. And that's allowed because objects do not live in any scope. Objects are all on heap. It's only the references to objects that are either attributes of some other objects or they are identifiers in some scope. Right? So things you should know about. Let me make a note here also. Objects do not have scope resolution. I say objects do not go through scope resolution. That's the, or against objects are not resolved via scopes. Resolved to scope. Only identifiers, variable names, function names. It's okay. Markdown. Let's make it a markdown. Only identifiers, which are variable names, function names, class names, module names, for example. Something that you should know about scope resolution. All right, so I talked about the scope. I also talked about the enclosed scope. Something very interesting about enclosed scope, I will tell you. That's a major use case for it. Let me demonstrate with another file. Let me define a function called testfn this time. And as usual, I have a function, inner function called foo. Now in testfn, I'm just going to define a variable as a is equal to 200, for example. And in foo, I can access that variable via enclosed scope. I can type in foo a equals a. Now at this moment, I'm just going to call testfn like this. The function is called. From the global scope, can access a. In main, a is equal to. Obviously, you know, it's an error, right? This is an error. You try running this. Let me save this as enclosed scope. Just type Python, enclosed scope here. It throws an error. It says in main, a is not resolved. It shows that a is not defined in the global scope because this particular variable is defined inside a function. You cannot access it outside. Some people who come from other language backgrounds, I guess JavaScript, would attempt this. Would say, okay, I can access a like this. Can I not say testfn.a? Should work, right? Oh, it's defined inside testfn, so I cannot access it. Try it out, and you'll be surprised with an error. So you may think that you can access foo from testfn by using testfn.foo. That does not work. That might work in JavaScript. It doesn't work in Python. I don't like that design. It's a horrible design. I think this kind of thing used to work in PHP. I'm not sure what's the case with PHP 7 or 8. I think the last version I used on PHP is PHP 5 or 4, if I'm not wrong. I moved out of PHP completely after that. I was very fluent with PHP till the last decade, I would say. Even now, I do a little bit of PHP once in a while, just fixing code, but I don't go deep down. It's been quite a long time now. It's more than 12 years. And things like whatever new features are being added, really not tracking it as much. It is, maybe I'll not comment on the language. It gets the job done. It did get the job done. It was a very quick way to get your web application done, but it had a lot of other design level issues. Okay, it's not very perfectly, cleanly structured language. Many things were done in a very haphazard manner in it. The design is not the best, I would say. That's my comment on it. But it's fine. It gets the job done. It is like Perl, practical. That's it. Anyways, so let's not get into that. But for now, let's talk about this as such. Some of these languages allow you to access any definitions of inside a function by using a dot operator. There are some functions, some languages do, but Python is not that. You can't try testfn.a or testfn.foo. It's not going to work. And the reasoning behind it is Python is a fully dynamic language. This variable called a gets defined only when testfn gets to execute. Remember, functions are objects. Functions are objects. But that object only represents the bytecode. But it's not alive. It's just there, sitting dormant. It's like a seed, right? Which you can't say it's alive until you sow it. So it's just there in memory, the function object. But the moment you call a function by using testfn open close parenthesis, when you use open close parenthesis against testfn like you did here, this brings the function to life. What does it mean by that? The act of calling open close parenthesis on a function actually tells Python to allocate a frame object, which represents the function state. The frame object represents the function state. And now the function bytecode is executed. And when the bytecode is executed that represents the function body, all the definitions are added to the frame cells, which live as long as the function runs. So the variable a is equal to 200 is added in the frame. Def foo is added in the frame, and the value would be a reference to a function object, which gets allocated, of course. The moment the function returns, that frame object is garbage collected, largely assuming there are no other references inside them. So the frame object is collapsed. That means the function completely tears down the state. Therefore, you no longer have access to foo or a because the function is not running. Now here's the dilemma. When you say testfn dot, you didn't run the function, did you? No. It's a function object. The function object is there in memory. Still that foo and a is not there in memory. It's like this. You have a seed. Only when you plant the seed and it comes to life, you can actually see the leaves sprouting out, right? The leaves come out only when the seed sprouts, when you plant it or when you sow it, right? Otherwise, it's just a seed. It does not have a life. So that's what this testfn is at this moment. So you might think, let me call it like this. But you know what? When you call a function, the function runs to completion, tears down the state and comes out. It's like a couple of these herbs, right? So you have like bean or some beans, which I know of. The French beans, for example. You sow a seed, it sprouts. It comes out to some size and it gives you more leaves and all that, flowers, and there are some seeds. And then what happens? It dries out. Done. Its state is gone. Maybe I get the return value, which is the seeds. From one seed, I might get about more seeds, perhaps, right? I could get maybe 20, 30 seeds, whatever it is, and I can sow it again. That's the thing with the beans, let's say. So think of a function like that. So when you don't call that function, the function is not alive. When you call the function runs to completion, returns a value. What does it return? Whatever the return value, right? It has returned something. But because I did not use any return keyword in this function to return anything, I did not use return statement here, so it returns none. And none object does not have foo. So the function's return value is what this dot operator will resolve on, not in the function. The function completes what it returns. On that I'm trying to invoke foo. Obviously, this also won't work. It says attribute error. In this case, if I save this now and run it this time, we'll tell none object has no foo because function return none does not have foo. Now you might ask me, how do I access the function's ingredients? Well, you cannot. Simple. You cannot. Because in order to access the function ingredients, the function should be running and you should be able to access it. You can't. Because when you call a function, the function runs, completes, the next line of code is after the function completed. So there's no access to it, right? So these are things you should keep in mind when you talk about these things. So this won't work. But however, there's an interesting hack, I would say rather, that Python has. And what is that? I call this function testfn. All right. So when I call this function testfn, in main, I think a is equal to a, you can see it does not have a here. We saw that code earlier. When I run this, in main a is not defined. It says that, right? In main a is not defined. Let's say I'm going to call foo inside testfn here. When I invoke testfn, this testfn defines a variable, defines foo in this case, and also invokes it, calls it. Now foo, when invoked, tries to access a, which is defined outside its scope, in the enclosed scope. It's able to print it. We saw that earlier, right? So we saw that earlier. We can see, yeah, you can see this. In foo, a is equal to 200. The value 200 is printed, right? In foo, a is equal to 200. This print statement is printing this line that you see here. But in main, that a is not accessible no matter what you do at this moment. But consider this. I don't call foo here. I'll return foo. What am I doing? I'm defining a variable whose value is 200. I'm defining a function whose name is foo. Then I'm returning the function, nothing else. I'm just returning the function. And I get this function in here. Under the name fn, right? Under the name fn. And I'm going to call fn in main. In main, I'm just going to call it. Maybe I can just say, fn like this. A is equal to 200. Now here's an interesting concept you should learn. You don't trust the outsiders. You defined a variable here. This is local to the function. You don't trust your callers, who is calling you. So you don't hand over this variable to them. You don't hand over the variable to them because you don't trust them. So you define a function of your own, and that function can access this variable, and you hand over the function to the caller. So if the caller needs access to a, it has to call the function. The function will just print the value of a. This is an accessor pattern. This is an accessor pattern. I'll just name it. What is an accessor pattern? This is pretty natural in many statically typed languages which use these private protected keywords for representing encapsulation. If you come from the Java world, it could be quite familiar to you. You define a class, you make all the properties or the attributes private, and you create get set methods, getter setter methods, right? Get name, get role, set role, get department, set department. So outside callers will create an object of your class, and they use these get set methods to access the properties in a safe manner. These getter setters will do all the validation if necessary. So that provides some kind of safe scaffolding. It's like you walk into a library and if you're given complete free access, people just clutter all the books, throw it across. So maybe you have a very restrictive environment where you have a librarian who is going to get things for you in a safe manner, and he's going to make sure that he's picking the book back from you before you leave the library, and he's going to organize things. So that's way you're not given access to the books directly. You have to call out the librarian, and he will actually work like a proxy to interact with all the books, right? It's something like that. So if you're not, I don't know about libraries. Libraries are generally free form, but when you go to some of these malls and showrooms where they sell exotic stuff like jewelry, that's how it is done. You go to a jewelry showroom in most of the places, at least in India, I know. It's not very free form. You can't just go and pick up jewelry as it is. They are being displayed. You go and try to pick it up. It's not accessible to you. There are people standing there. You just say, I want to see that. They're going to take the jewelry safely and stare at you and stand in front of you and let you see the jewelry. You can't just take the jewelry and walk out. They're going to just take it back, put it back there, and they say, which one do you want to see? You want to see that? Okay. So it's a safety mechanism. That is called an accessor pattern. It's not in your design patterns book, I believe. It's not in that. There are so many patterns that are there which is not covered in your design patterns book, which is the Gang of Four book, which is called. I think they have over 23 patterns, and most of these patterns are sort of shoehorned with Java and C++ in mind. Largely Java in mind. Not even C++, Java. That's what they are. They're like shoehorned with all of them with like Java mindset. Sadly, that book is, but the essence when you learn from that, you can apply in many languages. And this one of them, that's accessor pattern, which is quite natural in those languages. But in Python, you do it like this. I'll tell you the realistic use case for this time. There's an interesting one. I told you some time back that when you create a global variable that represents a list, it can be quite dangerous. Anyone can modify them. Any code can modify them here. Any function can go and manipulate this list. I want to scaffold this list. Oh, this time I'll use a set. I will show you something interesting. And this is how encapsulation can be done if you really prefer in Python. Though I should warn you, the code I'm going to show you is definitely not good practice. It is not Pythonic. It's not Pythonic, but it's doable. It's just a learning. It's good to learn how things work, right? It's just a small experiment which you're going to do here. So I have a function, let's say, called company. And this company takes arguments. I'm going to put start founders. Yeah, you can have company with many founders, right? And I'm going to make this founders is a tuple because when you do a star args, it takes multiple arguments in tuple. So when you are going to call it, you'll just type company of, maybe you can just type maybe John and Alice are two founders of the company, let's say. So I can pass multiple arguments, and all the arguments which you pass in here must be taken in as one single entity. That's what this tuple is. Takes variable arguments, positional arguments as such. And what I'll do here, I want to transform them to a set. I will do that. Or should I? Not really. Okay. I'll create something else. I'll just create staff is equal to set of founders for now. Create a set from the founding members. Founders are also staff of the company. It's a small startup, let's say. And then let's say there's a function, an inner function here, which is called hire, which takes a new member. I'm representing as M. And all I do is I'm going to say staff dot add of M. Closely observe, staff is a local variable of company. But because this hire is an inner function inside this company, it can access staff through an enclosed scope, or the external or the outer scope. Enclosed, external, outer. I'm going to use that interchangeably. Sometimes I can also use the word nested. It's all the same, right? So I'm going to access this from the inner function in here. It can access it, right? We did that with simple variables like A. And that staff is now representing a set. And a set has methods like add and remove. We all know that. So I can call the add method to add a member. Now, I can also have another function called fire. Obviously in companies, you hire when the economy is going up, and you fire employees when the economy slumps. I think we are in this side of the economy in 2024. I don't know when it's going to change back. So we all see layoffs and terminations going on. That's a reality. There's always a cycle of layoffs at some cycle and extensive hiring in some cycle. Okay, this is 2024, and yeah, I see a lot of layoffs going on since the last year. Anyways, and in here, I'm going to type staff dot remove of M. But I also want to add a small condition. Maybe the startup is like a little restrictive. Maybe you can fire any employee, but not the founders. assuming that they don't have any investors and the founders are the investors. If it is a big company, a large corporation, if it's not doing good, sometimes even the founders can be booted off from the company. We all know that. So I just remember the logic here where it say if, how do you check whether the staff, the member you're trying to fire are founders? How do you check that? You can see that founders is passed as an argument anyways. And all variables that are passed as argument to a function are anyway scoped locally. And this founders can also be accessed in the inner function using the enclosed scope, right? So you can actually use if founders. Now I should just say if member in founders, I can raise an exception. And this is how you raise an exception. Raise. I'm introducing you to raise. You want to raise an exception. I can invent my own exception class and all that. But for now, I'm going to live with an existing exception class. Let me call this value error. Value error. Of. I say cannot fire founding members. I don't need the else clause because anyway, if it raises an exception, there's no question of coming back down here. So it's fine. If you want, you can really put else there. It doesn't matter in this case. If you're returning up from a function in an if condition and the condition is true or you're raising an exception, you don't have to put an else clause. It's not really required because the control anyway goes out of the function with this. What raise does, it'll raise error, a runtime error in Python if this condition is met. Rather than just returning something, it raises a runtime error. So you didn't handle that. We'll talk about how to handle exceptions in the further sessions. Maybe 2 or 3 sessions from now, you'll learn about that. So I'm just going to type company of Alice and so on. But okay, before that, I create a hire, fire, staff. I want to also add one more function. Let's say show. I want to show off all the company members. So I can just say, you can call it as get employees or get staff and all the name, but it's okay. I call it show. And in here, I will not return the set. That's dangerous. What I'm going to do now is I'm going to return a string like this, which is comma separated staff members. So something very common. All these 3 functions are accessing staff. You can see staff here. It's a set. The set is local to the entire company. It's a local variable in the entire company. And through this local variable or local scope, I can access the set, add a member in hire, remove a member in hire. Of course, some validation being done. Even in hire, I can add a validation to make sure the member, the name must be a string and it must be, you can actually do this type checks. You can't just add anyone, right? You can just do this. You can just do a if type of M is str, must be a string. Type of M must be a string. And M dot, the member, let's assume, must be made up of alphabets, no numbers. You can't add a member who says John the Third, person with numbers in them, or not Elon Musk's son. Okay, no special characters allowed. So I'm going to use M dot is alpha. So we made up just alphabets, and yes, it'll not take first name, last name. We'll not worry about that. It'll just take a single word name now. We'll hide it. We'll assume that the names must be of single word for simplicity. Else, you can also raise an exception here. Raise value error. Name must be made up of alphabets only. I'm not sure if my English is correct there. Correct me if I'm wrong. I'm just going to let that be. And the last thing which I'm going to do, the final stuff I want to do is return, hire, fire, show. What am I doing here? I'm returning 3 functions. So when I have comma separated items in here that gets boxed into a tuple, it returns a tuple to the caller. So I just save this file I want to save it. Let me call this as company. I'll just call it company.py. That's sufficient. I created a file by name company.py, which is a Python file, of course. And inside that, I put a definition of a function called company. If you treat that as a module, company is a member of the module that you can access, which I will show you in the notebook now. I'm not going to run this, okay? So I want to have only the function definition here. You can also have a if name is equal to main and do some tests, but it's okay. I'll try to show it to you this place. Let me just save this and exit. Exit this. Exit this. Okay, let me go back to the notebook. And in the notebook, what I want to do is I want to just try to say from company import company. Company.py is that file that's loaded as a module. In that module, I'm interested in the function by name company. It's okay to have it like that. You know, if you have a module which represents just a single function, it looks intuitive to have the module name and the function name to be the same. It's okay to do that. From socket, import socket. From glob, import glob. You see that in real world with Python standard libraries. So it's perfectly okay to do this. And now, when I call company and pass on some arguments, let's say Alice and let's say Jonathan, you can see it returns a tuple of 3 functions. Here's a function that returns a function, right? Interesting. And now I'm going to capture those 3 functions and call them as usual, hire, fire, show. It's in that order. First function returns hire, second function is fire, third is show. You can give any names you want, but I'm just calling it meaningfully, hire, fire, show. So capture them as 3 different variables. Actually, these are identifiers that represent the function object, right? So I can now call hire of Alan, hire of Steve, hire of Elisa, hire of maybe Evans. Hired a couple of members. Yes, did so. If you want to see who they are, who is there in this company, you just call the show function. You see that? There are 2 different functions. Hire is one function, show is another function. Whatever I called in hire, like Alan, Steve, Elisa, Evans, you can see them all listed here. Steve, Evans, Alice, Elisa. The order might not matter because it's a set. If you want to maintain the order, you can use a list instead. Now let's try to fire somebody. Maybe the economy is going down. We are losing startup funds. So let's find whom to fire. Okay, let's try Alan. Let's try fire of Alan. Sorry, Alan. And do a show now. Alan's missing. It's not no longer there. Let's try to fire Alice. And it's going to fail. We all know that validation rules. Alice is going to fail. So it doesn't let me fire founding members. You can see this is a result of raise. The moment I said raise and I said value error off, when I pass a string, it raises an exception. See, there's a line that raises the exception. It's in this condition. It throws the entire trace back to show you where that exception is raised. So you need to gracefully handle it if necessary using a try except block, which I will cover much later. If you also try to hire with some arbitrary data, let's say hire of 1, 2, 3, it's not going to work. Again, I get a value error. You can see this. This is my own custom error that I added. So it raises value error. Name must be made up of alphabets only. Now you can see that I've created this function. It's a function. I create a function called company, which has 3 functions which are inner functions called locally, and I'm returning them. And these 3 functions have access to stuff, but they can be called from outside, right? Called from outside. Now here's the thing. Here's an interesting scenario where this company function is called, right? It creates a set. But do I have access to the set from here? Can you think of any ways to access the set? If you can find out, let me know on comments. But I couldn't. I can guarantee you that. I tried. I couldn't with all the values. I can know there is a set maybe if you look at all this function attributes and all that, but I cannot change anything, right? So it says company of Alice, Jonathan. It returned hire, fire, show. I can call hire of Alan, hire of Steve. So it's actually going modifying the set which is available through the enclosed scope. So these functions are working together. Hire, fire, show. They're working together. They're sharing a set which is created by company, and one of them is adding to the set, another one is removing from the set with some validation, another one is axing all the members of the set and returning it as a string which is joined out. So these all are scaffolding or encapsulating that set. This is encapsulation for you. This is exactly what encapsulation means. You have some data which you believe is very unsafe to be made accessible to the public, but you want to have a very controlled access to the data. So you enclose it. So here you enclose it by making it a local variable. Local variables cannot be accessed from outside the function scope. Never. Python doesn't allow you to do that. So by making it a local variable, you're making it totally private to this function. But however, you want to have a very controlled access to this where you trust these functions to do their job correctly. And you know for sure that they don't corrupt the data. If there's any problem, if the stuff gets corrupted, the culprits could be these functions. You need to fix the bug in this. And that's, you know exactly, there's a control access. So no other functions or no other code outside the scope of company can manipulate the set. This is how encapsulation is done. But is this a good thing? No. No. Some of you might come from C++ and Java and say, wow, we can do this, we can use it. But this hurts maintainability. So in runtime, if I want to do some diagnostics and want to find out what's the value of the set, I rely on these functions to return things. And if these functions are not doing the job correctly, it's a dead end. So from the debugging standpoint, debugging perspective, it can be very difficult and can be a little bit of a nightmare. And also the fact, this looks quite complicated, isn't it? This is no longer a beginner program. If you made it so far, watching my video, you might have wondered, oh, this guy said programming from the very basics. So what the heck is going on? He's talking about all these stuff, encapsulation with nested functions and all that. Yeah, this is what Python is. And all of these are fairly advanced topics, fairly advanced. Not really the basics. It's fairly advanced and can be complicated. It can be. So many of them who did some self-learning and may not be aware of these things, all this jugglery which I'm teaching you, they would struggle at this code. If they don't know scope, they don't know how enclosed scope works, this code might not even be readable. So don't put this on production. It's good for learning. Maybe you can find a use if you're able to manage things. But there's a bigger problem, I'll tell you from the design. Here are three functions. Hire, fire, and show. By looking at these function calls, it's not quite obvious to anyone that these three functions are sort of connected and they share a common state, right? Now imagine I create another company. I call company one more time. I call company function one more time. It creates another three set of functions. Now you can call them as hire one, fire one, show one. And now it gets totally messed up. You have a lot of functions lying around. You don't know, oh, hire is related to show and hire one is related to show one. It gets really a mess over. And this is what the truest inspiration or motivation for you to create object-oriented code using classes. The moment you use classes, that's what you're trying to achieve. These functions would become methods of an instance of company. So you say company1 dot fire, company1 dot hire, company1 dot show looks more properly structured compared to just having them as loosely ended functions like these. These are also functions with side effects. These are truest examples of functions with side effects, by the way. So I'll just put a note here. The functions hire, fire, show are interlinked. That means share state, right? Which is the set, which is defined in company, by the way. And that company function just does its job, throws three functions at you, and just goes off. That's it. The company is no longer in the picture. Once you call company, creates all the stuff, goes off. Now only these three functions are lying around, and you don't even know that they are all like they sharing states. That's the problem, right? So maintain ready can become a nightmare when you design code like this. So this is the kind of design you should avoid. It's fun. It's fun to learn. Sometimes all these things are funny, fun things to just give some exercise to your brain, let's say. But beyond that fact, you don't want to put this kind of code in production. Know this. So these are also functions with side effects. These are also functions with side effects. So with this, I complete all the things that you should know about scope, all the aspects that you should know about scope. The next session, I'm going to introduce you to another concept. I'll talk about lambda expressions. I'll talk about functional programming concepts. That's the next series, next version, next part of this sessions on functions, where I'll talk about functional programming concepts, the concept of higher order function. This concept of pure function is a term used mostly with functional programming languages, by the way, right? So Python is a multi-paradigm language. You will see these terms like pure functions and higher order functions are all used in pure functional programming languages like Haskell and Lisp and Clojure, all these kind of languages, right? So this is a feature. It's available in Python too. You can apply all these things, but don't do this design. That's the last thing I want to tell you. It's good for learning. It's a good exercise. It's a good thought exercise, right? To see how Python works and a lot of things that are available. So I'll end this video here. So I'm going to stop this video at this moment. It's already 1 hour. So I'm going to make another part of this functions series, where I'm going to talk about higher order functions, lambda expressions, and interesting built-ins which are available like map, filter, reduce, and a couple of reduce helper functions. I'm going to put that together and wrap up functions with that. And after which we will move on to some interesting stuff. We'll talk about file IO. I'll tell you how to handle files, how to read files, a couple of standard library modules, and then I will give you a whole lot of exercises. I want to put all the exercises at the end. So this time I just want you to try these things out, try all this code out, experiment with this code. If I give you exercises to solve, that's like a detour. It's good. Some people like to do it with exercises, but it's going to be once you know the syntax very well, once you become completely confident with the syntax. That's why I'm not putting a lot of exercise at this moment. So hang in there for another few more sessions. I will give you a couple of exercises which you can try out, which obviously you're post in a comment, and that's the only way I know whether you're going on track. All right then. So with that being said, if you're not subscribed to my channel, please do subscribe. If you like all these kind of videos like this showing up in notifications, do subscribe. And if you really think all these concepts I'm covering is adding value to you, if it's informative, if you're really learning something, please do hit on the like button. That way I know that I'm going on the right track. Thank you very much. So meet you in the next one.